Welcome to the Explainer. Today, we're cutting right to the core of what leaves our digital world so dangerously exposed. We're going to be tackling Objective 2.3 of the CompTIA Security Plus exam. This means demystifying the actual, real-world operating system and web-based vulnerabilities that lead to those devastating data breaches we hear about literally every single day.
Okay, let's dive into this. It's kind of the ultimate cat and mouse game, right? We build these massive digital walls, and attackers, well, they just look for the tiniest cracks. This isn't just academic theory, it's a high-stakes, ongoing battle. So how do they actually break into systems? What are the real mechanisms they use to bypass our defenses?
Section 1. Understanding System Vulnerabilities. And to ground us here, keep in mind we aren't just looking at dry certification terms. We are exploring the exact, real-world flaws that lead to data breaches.
Section 2. Operating System Weaknesses. Let's step onto our first major battlefield.
Think of your operating system, your OS, as the concrete foundation of a house. It manages all the hardware, right? It provides services for literally every program running on it. But if that foundation is cracked, well, it doesn't matter how strong the locks on your front door are. Because the OS sits at the absolute bottom of the software stack, it's a massive, highly prized target for malicious actors. Seriously, if they control the OS, they control the whole shebang.
So, how does that foundation get weakened in the first place? Well, it generally comes down to three main culprits. First, improper configuration, meaning someone simply set the system up wrong and left a glaring inherent opening. Second, outdated components. Think about the massive Equifax breach a few years back. That was, at its core, just an unpatched, aging piece of software. Crazy, right? And third, inherent design flaws. These are mistakes literally coded into the system's design from day one.
So the crucial point is, how do we actually defend against this? It requires a strict playbook for system admins. To fight outdated components, you absolutely must adhere to regular, rigorous patch management schedules. To mitigate those inherent flaws, you've got to apply the principle of least privilege. Basically, give programs and users only the bare minimum access they need to function, nothing more. And to catch improper configurations, implement robust monitoring and logging. Continuous patching and vigilant monitoring are for sure your best friends here.
Section 3. Web-based attacks. Let's talk about SY0-701.
Now we're shifting our focus from that deep internal foundation outward to the next layer, web-facing applications. Web apps are massive targets simply because, well, they're designed to be accessible to everyone. Weaknesses here act as literal open doors. They invite attackers right past your network defenses to perform unauthorized actions directly within those systems if they aren't guarded correctly.
What's really interesting here is how attackers exploit these open doors. They use Structured Query Language Injection, or SQLE. Now, SQL is the language used to manage data inside relational database management systems. In this attack, a hacker sneaks malicious database commands directly into normal user input boxes, like a login screen or even just a search bar. So instead of searching for a name, they type a command that says, drop all tables. And the database just blindly executes it, letting them manipulate the backend completely. No way, right? But it happens all the time.
Okay, so how do we shut down these database tricks? Here's your defender's response. First, strict input validation. You must verify absolutely everything a user types in, no exceptions. Second, parameterized queries. This is a real game changer because it forces the database to treat inputs strictly as text data, never as executable code. And third, limit your database service accounts using that principle of least privilege again. That way, if an attacker does get in, they can't just burn the whole database down.
Section 4. Cross-site scripting. The XSS threat.
This is our final and arguably sneakiest threat today. While SQLI attacks the database sitting behind the web app, cross-site scripting, or XSS, turns the web application into a weapon against other users directly. It injects malicious scripts directly into web pages viewed by victims. And this brilliantly illustrates a terrifying concept. It weaponizes trust. The user completely trusts the legitimate site they're visiting, and their browser blindly trusts the script.
XSS comes in three primary flavors. First, there's stored XSS. This one is highly dangerous because the malicious script is permanently saved on the target server, hitting literally anyone who visits that specific page. Second is reflected XSS, where the script is cleverly embedded into a manipulated URL, affecting only the people tricked into actually clicking the link.
And finally, DOM-based XSS. This occurs entirely within the browser's document object model, meaning it manipulates the page elements right in front of the victim without ever even touching the backend server.
To stop these unauthorized scripts in their tracks, defenders use two main strategies. First, we once again rely on input validation to sanitize user inputs, basically scrubbing away any potentially malicious script tags before they're ever processed. Second, we implement a content security policy, or CSP. A strong CSP acts like a strict bouncer for your browser. It explicitly blocks any unauthorized script from running in the first place.
As we wrap up this explainer, I want to leave you with a rather provocative thought. Is your system truly secure, or is it just waiting to be tested by an attacker? We've seen today that whether you're talking about protecting the deepest operating system foundation or that outward-facing web application, the core philosophies of defense are exactly the same. You've got to rigorously validate all inputs, relentlessly apply the principle of least privilege, and maintain a strict schedule of patching and updating. Security isn't just a one-and-done setup, it is a continuous, active process. Thanks for hanging out with me today to demystify these critical vulnerabilities. Now go take a really hard look at your own systems.